Hi everyone, today we are performing an experiment called as characteristics of GM counter, that is a GM counting system. Let's see the aim. This is about the aim. To determine the characteristics of a GM counter using a beta or gamma source and plot a graph of number of counts per second against the applied voltage, and to determine the operating voltage. This is about the aim, and formula is where the V0, that is what operating voltage, is equal to V1 plus V2 divided by 2, where the V1 is the plateau voltage and V2 is the end of the plateau voltage. In the graph we can see that this is the nature of the graph. Along the y-axis we are taking the count rate, along the x-axis we are taking the voltage. So this is Vs is known as the starting voltage, that is starting voltage, and V1 is the plateau starting region, and V0 is the operating voltage, and V2 is the end of the plateau. So this all about the nature of the, and here I am sample using a cesium 137 and the background count for 60 seconds. I am setting the time for the 60 seconds. Next I will show you how to set the times and all. And before that, this is what the GM tube looks like. It's a GM tube where the completely filled with the noble gases. Here the particle detection takes place. You can see this carefully. This water tube, and I am going to fix it here. Let's wait, I will show you how. By fixing like this, I have to place it like this here only. After this one, this will be fitted, and using this thread knob you can fit it. We can fit it, and take the cesium 137 sample. Take the cesium 137, you can see it carefully, cesium 137, and this is the base place of the radioactive substance. And what we need to do is we have to place this one like this only, because if we observe this end from carefully, we will see a one inside a thin layer, so which is oppositing in the direction that should be in the below only. So by taking this one, place the sample carefully, and and mount it back, and mount it back without disturbance. And then what you need to do is just turn on the gem counting system. Now what you need to do is just turn on the gem counting system, and it will show a gem counting system, nucleonic systems, and accurate mode, high voltage, and the precise time it shows. So next what we need to do is just press the program, and the precise time is, it is what, 300. 300 means it is in the form of a seconds, that is 300 seconds. It means that it is of the order of 60. 300 divided by 60, that almost comes around 5. Then it is the precise time is 5 minutes. So what we need to do is, by using the this, by pressing the above key and bottom key, we can set the time here. So it is in the second, I already told you. If we press this one above button, it will show the numbers 1 2 3 4 5 6 7 8 9 and 0. So this is about the 1 second, 2 second, 3 second. If I do it, make it as a 0, then what you need to do, if I want to get it for a 60 seconds, so that 3 4 5 6, and this 3 I will going to make it as an 0, so that it's for an experiment for an 1 minute. And next I need to save this one, so I will again press the program. So these are the readings, how many readings I am getting, that is 0 0 0. Now it is start counting where the voltage is only 1 volt, and the label. When I connected this one with the computer, I am going to name it as an reading 1, reading 2, reading 3. So this one, since I am not going to connect it to the computer. And these are the interaction I am taking only one, since I am using an here cesium 137, so that it gives an interaction of only beta radiation. So I am counting only beta radiation, that's only one. And if I need to save this one, I can save it in the computer, and data is completely off. And if I have done any other memories within the previous experiments, they can be taken and they can be erased here only. And print data, these all can be set towards in the computer. I will show how where are the keys are. through this through this GND plus 5. Then from this one I can connect it to the computer. I connect it to the computer, and again the store, I can store this one in the computer and store data without the high voltage by excluding the voltage. By expecting the voltage, I can exclude the voltage and take the readings. And this PA time means parallax time. I need to maintain it as an off. Parallax time should be an off when I am connecting with without the computer. And the accurate mode is the, and precise time, everything will be stored. Then I am going to start the experiment, and I am going to start the experiment. Here the countings, and counting is completely 000, and the high voltage is only 1 volt. So next high voltage is only 1 volt. Then what I need to do is by increasing and by increasing and 20 volts, I need to make it as a slowly by increasing at 20 volts. So 20 volts, PT means the precise time and ET means the estimated time. So how much seconds it taken? Now it is taken at 27 seconds, 28 seconds, and here the counts completely, it is 0. So from the previous data we know that we are not getting up to the voltage of 340, around 380 voltages. I'm not getting any counts. So what I'm doing is, previously I know it, but for the process purpose we need to take it for the 20 volt should be increased. Then at what time I am getting, so directly I will go to a voltage of 320 volts. Slowly we should knob it. So this is 320. Then again I will start it. So here I am not getting any programs, so any count rates, sorry. So again I will increase up to 20 volts, that is 340. Again I will press start. So now also no detection takes place, and again I am going to for the 380. So you can observe here the particle count rate is started. Then again press, and now press start. So in 1 minute, how many particles are detected? It can be recorded in the tableau column. So for the trial number 1 of 320 volt, it shows 0. For 340 volt it shows 0. For 360 volt it shows 0. Now I have kept it for the 380 volts. So wait up to 60 seconds, and the estimated time also 60 seconds takes place. There are 771 beta particles are counted. So what I need to do is write 380 volts and 771, and take these readings up to a certain voltages. Up to, you can take it as the maximum counts as 1000 volts or less than the 760 volt, and note down the count rates and plot the graph. Or it almost, by plotting the graph, it almost look like this only by the plateau region. And this is the V1 here, sorry, here there is maybe mistake. So this is an V1 and this is the V2, and operating voltage can be counted. Approximately the operating voltage of an GM counter comes around 500 volt. This is the operating voltage, and it works on the principle of Townsend and Avalanche principle. Now what you need to do is, again for taking the background counts, for this the background counts for 60 seconds, then what we need to do is just remove the sample and press start by keeping it into an operating voltage. That operating voltage is By calculating, we are getting up to 500. So 500, then press start. If how many counts are coming in the operating voltage of 500, after completing the complete estimated second of 60 seconds, that is, so the background count is 75 counts. Then note down NB is equal to 75, and by using the calculations, that is V0 operating voltage is equal to V1 plus V2 divided by 2. It comes around where the V1 is equal to 440 volt plus 600 volt divided by 2. Add this one and 2, that gives the around 520 volt. If this is what around the 400, it comes around the 500. This is the starting voltage, this is the end voltage, and this all about the experiment.